Hey guys, so yesterday we looked at the different types of lenses that we can use or see in daily life, be it the convex type or the concave type, right? We also said we focus on only two lenses, the biconvex and the biconcave, or simply convex and concave. Today what we are going to do, we are going to look at how light behaves with these lenses. So if light is falling on any of these lenses in different ways, what's going to happen? So if you remember, we had rules of reflection in mirrors. Same way we are going to have rules of refraction for lenses. Okay, same analogous. Alright. So if you recall, we have this lens, the convex lens, and we have the concave lens. So when we draw ray diagrams, we will be changing these diagrams to this. Okay, the convex lens is drawn like this. It's like an arrow pointing outward. And a concave lens is drawn as arrow pointing inward. Okay. The arrowheads point out or point in. This is a convex, that is a concave. Alright, just to make drawing easy. So we'll look at four different situations in our reflection today. We'll look at them for both concave and convex at the same time. Refraction. Okay. So we know that our diagram looks something like this, right? F1 C1, F2 C2. Okay. The first rule is very simple. Okay. The first rule talks about what will happen if a ray of light goes through this principal axis. Okay. What if there is a ray of light coming in this direction? Okay. It's quite simple. It will go along this line like that. What happens once it hits the lens? It is going to continue in the same direction. Okay, it will just keep on going forward. So whenever a ray of light is incident on the principal axis, we could say incident on principal axis, means it is coming through principal axis. So then it will pass through without any deviation. There is no refraction happening there. It comes straight, it goes also straight. Okay. The same is true even for the concave lens. Okay. So I have the lens over here. Right. Again, for this, even if the light is incident over here, it goes through the principal axis. Same for both. Right? This is the rule number one. What is rule number 2. Okay. So rule number 2 talks about, if you remember, every lens has something called an optic center, right? The optic center, like we discussed, is nothing but is this geometric center of the lens, right? So what happens if my light goes to that? It's quite simple. Again, similar to this, it will pass through without any change. Okay, so this is my lens. This is the optic center, right? What we call as O. So if a ray of light is going through O like that, okay, this is my incident light. Then it will go back and go through the lens, same direction, no change in angle whatsoever. No deviation at all. Okay, so I can write this as no deviation. Both of these are the same. All right, no deviation of light. By deviation, I mean to say change in the angle. Okay, same goes for this. I'm coming to optic center. It doesn't matter at what angle I come. Even if I come like this or like this, long as I'm going through center, it will definitely go through out in the same way. Right? No deviation in both of the cases. Now, we'll move ahead to the next case. What if light is parallel to this principal axis? Okay, so for the case where concave lens, convex lens, now what if ray of light is parallel to it? Right? Principal axis, ray of light, both parallel lines. Yes. So what if these lines are parallel? Then after hitting the lens, it will bend such that it goes through F. It is definitely going to pass through the focus on the other side. Okay, same goes for this side. If I have any ray of light coming like this, to hit and pass through F. Okay. Sorry, my diagram is a little bit messy. I will clear it. It is going to pass through F. Alright. So all the light rays, if they are parallel, they will definitely come and meet at the same point, which is F. Good. Same applies for this. Not same but similar. Alright. Assume Now again light is coming parallel. What more? Now the difference between concave and convex is, in convex the light tends to merge or come closer. Over here in concave the light tends to diverge, okay, or go away. So what happens is the light is going to go like that. Right? Now the light went out, that is fine. But what happens is, if you look at this point and the direction of this light and you go backwards, if you trace back the path, it will look like it went from F all the way there. Okay, it will look as if it is going from F through that. Same goes on the other side of the lens also, right? It will first diverge, but if you trace back the path, it will look as if it's a straight line from the focus, right? So whenever rays are parallel, in convex they meet at focus, and in concave they look as if they meet at focus. Okay, does meet, looks like it meets. That's the only difference. We'll go for the last case, the final case. Again, I draw a concave and a convex. First go with convex. Then we go with concave. Right. Now, the fourth case is pretty much the opposite of this case. Okay, here it's coming parallel, but then it goes and meets the focus. Here is the reverse. We say it's coming from the focus. Okay, so what if there is a ray of light that's coming all the way from here and goes through focus? So that looks something like this. So from focus, a ray of light goes out like that. See, so from focus, light is going out, hits the lens. What then? So if parallel goes to meet focus, going from focus should become parallel, exact reverse, right? So it's going to become parallel to the principal axis. Same goes even this side, right? If it comes out of focus, it ultimately just becomes parallel. Okay, so any light that passes through focus upon hitting the lens becomes parallel. Now what about this one then? Because light doesn't pass through the focus here, it will be something like this. Alright, so let me just make it a tad longer. Okay, over here what we will say is, we will say that the light moves in a way that it looks as if it had passed through focus. Alright, so let's say there's a light ray that comes then it should become parallel like this. Later again comes like that, it should become parallel like this. Okay, now where does it look like it is meeting the focus? Right, you need to extend it to this focus. Okay, it will look as if it was going straight, it would have hit the focus, right? If the lens was not there, it would have gone there. Same, even for this slide, the lens wasn't there, it would have gone through focus. So, by any ray of light that appears to have gone through focus, it will become parallel after hitting the concave lens. Okay, so these are the 4 major rules that we will be using whenever we draw diagrams for objects, right? Like in mirrors, we had object here, image here. Similarly, we'll have diagrams here for this. Alright, so it's quite a simple, very small topic. I hope you understood. Taking notes, make sure you refer to this. Next class onwards, we're going more at drawing full scale diagrams. Cool. Okay. Thank you so much for being part of the class, and I hope to see you in the next class.